This video is on section 5.3 in our geometry textbook, which is all about inequalities in triangles. Let's start by talking about the comparison property. So if A equals B plus C, so some quantity is equal to 2 added together, and this C is positive, that's important, this C is positive, then your A has to be greater than B. Because if I take B and add something to it in order to equal A, A's got to be bigger than B, greater than B. That's the comparison property. Here's one example of how that is seen in triangles. So triangles have often an external angle that I marked as angle 3. And we know that the external angle in a triangle is equal to the two non-adjacent angles added together. So the measure of angle 3 is equal to the measure of angle 1 plus the measure of angle 2. So therefore, angle 3 has to be greater than angle 1, and angle 3 has to be greater than angle 2. That's all the comparison property says. Here's another example of how we can apply the comparison property in triangles. I have triangle XYZ, and there's a segment through the middle that's YP, and I've labeled these two angles 1 and 2. And I'm telling you that the measure of angle XYZ is equal to the measure of angle 1 plus the measure of angle 2. That's the angle addition postulate. So hopefully we realize that. The big angle is made up of the two subdivided pieces added back together. So what do we know about the comparison between angle XYZ and angle 2? Are they equal, or is one bigger than the other? Hopefully you see that angle XYZ has to be greater than the measure of angle 2. If you had to justify that on a proof, you would say the comparison property. Here's another example of using the comparison property in the exact same triangle. Now I'm going to deal with the segments that are created. So if XP is less than XY, and ZP is less than ZY, then XP plus ZP, so this plus this, would compare how to XY plus ZY. So notice I've added the two smaller segments together here. These are the two greater or larger segments added together here. So what do you think the relationship's going to be? These are still smaller, right? So this should be less than. Hopefully you see that. If I wanted to justify that, I wouldn't just say the comparison property, because I've added to it. See, I've added to each side. So therefore, I would say the addition property of inequality, not the addition property of equality, but it's still the addition property because I'm adding to both sides, but it's the addition property of inequality. Let's look at another example of inequalities in a triangle. Here is triangle ABC, and I am telling you that side BC is greater than side AB. What you want to know in triangles is that the longer or the larger side is across from or opposite the larger angle. So if you look at this triangle, BC is the longer side, it is across from angle A. AB is the smaller side, it is across from angle C. The larger angle will be across or opposite the longer side. Therefore, angle A has to be greater than angle C, because the side across from A is greater than the side across from C. That relationship works in all triangles. Of course, if the sides are equal, then the angles across from them are also equal. That's our isosceles theorem. So if it's longer, then it's greater. So if you were given a triangle like this and you were asked to list the angles in order from smallest to greatest, then the smallest angle would be across from the shortest side. The shortest side is LM, so angle in would be the smaller angle. So angle in is less than, and then the angle in the middle would be across from the medium length side, which would be LN. So that would be angle M, which would be smaller than the greatest angle would be across from the longest side. So that would be angle L. It's a little bit tricky writing these angle symbols across from these inequality symbols, so just do the best you can. The reverse relationship, or the converse, is also true. The longest side would be across from the greater angle. So the measure of angle A is greater than the measure of angle C. So if the measure of angle A is greater than the measure of angle C, then that means BC, which is across from angle A, has to be greater than AB, which is across from angle C. So BC has to be greater than AB. The longer side is across from the larger angle. Let's say you were given this illustration, this drawing, and you were asked to list the sides in order from the longest to the shortest. So to find the longest side, you would look for the greatest angle. The greatest angle is here, 81 degrees, and opposite that angle is side AB. So AB has to be the greatest side. The next largest angle in this triangle is 67. So that would be BC. And then the next one would be AC. So AC is the smallest side in this large triangle. It would be the longest side in this smaller triangle. Be careful that you don't try to put the two triangles together, if that makes sense. So AC is the biggest one here, which we've already listed. The next largest one would be across from 54. It would be CD, and then the smallest one would be across from angle 51, which would be AD. That's how you do it. Be really careful that you don't mistake this one. Yeah, this is the longest side in this triangle, the shortest side in this triangle. So that, because they're right up against each other, it's a little bit more complicated, but in essence, the greater the angle, then the longer the side that's across from it. Two other relationships that you need to be aware of in this section is, how does this work in a right triangle? In a right triangle, the right angle, the 90-degree angle, is always the greatest angle. The other two are always going to be acute angles, less than 90. So therefore, the hypotenuse will always be the longest side in a right triangle. We've seen that in using the Pythagorean theorem, so that should be, hopefully, logical to you, but just remember that is a theorem. Another theorem, which I've stated before, but now I want to make sure everybody understands. If I have this point here and this line, the distance from that point to the line is always the perpendicular distance. That's the shortest length. So if I want to find the distance, I need to be perpendicular to this line. Anything else other than that would be longer, and so it would not reflect the distance correctly. So this section is all about exploring different ramifications of that, finding the longer and the shorter sides, the larger and the smaller angles, looking at right triangles and the shortest distances and that kind of thing. And that's, hopefully, it will make sense and not be too complicated. Think it through logically, and I think you guys will be just fine. So that's it for this video.